Welcome back. Our next presenter is Charles G4GUO, who was actually introduced into the world of ATV at university by Dave. He was active on the original 70SEMS analog TV in the late 70s and 80s with the well-known Worthing Group, and then re-established interest again with digital ATV, first with DATV Express and then the BATC NUCA DVB-T project. But today he's here to share how he uses AI in this hobby, how useful it is now and where he thinks it's heading. Don't forget your questions and comments on the chats during his talk. Welcome, Charles.
Oh, welcome, Dave, and thank you very much for the introduction. The hopefully this will be of some interest to people, and it's the reason I haven't been too active on amateur radio recently is the arrival of artificial intelligence. Now, what I intend talking about is just my own journey into artificial intelligence and what I think may happen in the future. So as we'll move on to the first slide, hopefully. Whoops. Right. In the beginning, I bought a book on CUDA because I wanted to accelerate software-defined radio, and using parallel processing seemed to be a way to do it. That was back in the days when sound video cards weren't that powerful. So the first thing I learned about was how CUDA kernels work and the different types of memory in a GPU. The type of memory is the most important thing to understand. Originally, you actually had to do it all manually in the first versions of CUDA. You had to actually, when you needed to put memory onto the GPU for processing, you actually had to do a mem copy, or the equivalent of mem copy the data onto the computer, onto the GPU, I should say. The latest versions of CUDA, they have managed memory, and it does it for you. When you want to use some memory on the GPU, it knows that it needs to transfer it from the CPU and does it transparently. But actually, to do artificial intelligence these days, you don't need to do any of that stuff. The next project I tried was LDBC code decoding. That's the error correction scheme that's used in DBVS2. It's very computationally expensive, and normally it's done in specialized chips inside the receivers. But the using a GPU to do it is not that a great idea. The work came from a university in Sweden where they'd done something similar, and the problem is there's an awful lot of latency, and you can do error correcting on gigabits per second of data using a GPU, but it's the latency really kills it. And then the next thing I tried was with the CUDA FFT library. I thought, oh, this'll speed things up, but it doesn't really, because again, moving data from the CPU onto the GPU is the slow part. And FFTW, you know, was it the FFT program that's supposed to be the fastest in the West, that the performance of that is not that much difference for the type of applications that we want to use. Okay, and then along came AI. This is actually quite an amusing story. One of my relatives' girlfriend was about to start a PhD in AI, and I was talking to her, and I was saying, oh, I said, AI's been around for ages, and it's always been the promise of tomorrow, and I think you're wasting your time. And she put me right on that. So anyway, right. Well, I first started off the normal thing, learning about perceptrons or perceptrons. They're the very basic neural engine type thing. It looks like a human brain or a brain cell, and they're very, very simple. And that's the sort of page one of the book when you're trying to learn this stuff. And then that's obviously followed by deep neural nets, whereas when you've got multiple layers of these things all talking to one another. And then back propagation is the way they update the model. It uses the a version of the chain rule in differential calculus for those mathematicians out there. But when you're trying to learn this stuff, the most of the books they start off with basic mathematical processing of things like grouping, curve fitting, and grouping things into clusters and stuff like that. And it's not always that interesting. It's a bit tedious, so you tend to skip through the books. Well, that's the temptation. But I tried to resist that and actually read all these chapters, and I can't remember any of them now. But anyway, I even did some free education with NVIDIA. They were doing a training course for the Jetson Nano, and it's a multiple choice question, as you go through all the lectures, and at the end, if you get above a certain number, they send you a certificate, and so that's my only qualification in artificial intelligence. Right, my first project, I thought, well, let's try some transfer learning. This is where you take a model that's been trained on something else. In this case, it was a model called MobileNet or MobileNet 2, version 2, to use the American pronunciation. And it's originally it's designed to detect objects like cars, pedestrians, computers, rabbits, cats. It's just a general purpose object identification algorithm, mainly based on what's called a convolutional network, which is just a way of doing the process. It's similar to convolution used in signal processing. The idea is the same, but it's all done in little boxes and what have you. And then, as I said, you use transfer learning, and the way that works is that in this particular case, you created a directory with a load of or a load of directories with the objects you wanted to train on, and then you put pictures of the various items in each of the or thousands of pictures in each of the folders, and then you start the training algorithm, and it goes around and it retrains the top layers of the model to actually recognize these objects. Now, after an awful lot of effort, I did actually get something working. Now, this is QO100, and it's been trained on obviously a spectrogram of the received signals, and you can see that it doesn't get it all right, but it gets some of it right. And I think there was about 1,000 or so training samples on this, and it was all done by me by hand, and as you see, manually trained. And the training consisted of taking my cursor, selecting a piece of the spectrum, and then labeling it, saying what it was. And it's very, very time consuming. It's like that's the biggest problem with artificial intelligence, is getting enough data to do the training. So that worked reasonably well on QO100, but when I tried it on an HF signal, it didn't work at all. Well, it sort of worked in that it had never seen an AM signal before, and it thought it was an SSB signal, which to a certain extent it is. But I think this is the 40-meter band, with the top end of it at the bottom being the broadcast part of the band. But to fix this, obviously not enough training data was available. And rather than do it manually, you want to probably use something like GNU Radio to generate waveforms and then put them through channel simulators and totally automate it. So it literally generates tens of thousands of training samples. But artificial intelligence may not be the best approach to this. It may be better to use some of the classical things like looking at the width of each of the individual signals and the amount of amplitude variation across the signals and phase alterations and stuff like that. But that's pretty much where I lost interest in doing this. The next thing I tried was combining radio and speech to text. There's models like Whisper from OpenAI, which are open weight in that you can incorporate them in your own code. And they'll turn human speech into text. They can also translate between languages, so they're quite useful if you're trying to translate some foreign languages. So I tried two different ideas. The first was simply to pipe audio from a receiver, a standard amateur receiver, into a sound card and let Whisper do its thing. I tested that on a Russian language AM broadcast on HF because I don't know any Russian. And as you can imagine, it was mainly talking about the what's been going on in Europe recently. I also tried it on some of there's a load of, I believe, Russian pirates that operate above the 80-meter band, and I tried it out on them. And they seem to be either the conversations were mainly swear words and various people boasting as to how good their homemade alcohol was and stuff like that. So it was quite interesting to say the least. The next thing I did was to connect GNU Radio to Whisper. So I just piped it out of GNU Radio straight into Whisper. And this time it was on listening to NBFM, which is much easier to do. And it's apart from knowing it worked, I guess you could use it for listening for rare CQ calls on 2-meter FM, or when I was first licensed, the 2-meter band was alive from end to end. I mean, these days there's nobody on it. Well, I never hear anybody on it. But there are some problems with using something like Whisper, which is really designed for general conversation and long conversation, in that it doesn't like short overs because it can't build up enough history to work out what's being said. And it doesn't really like amateur radio call signs either because it's never seen them in its training data. So it struggles with that. So the lessons I learned with SSB, obviously you need to have some form of frequency offset correction because it needs to be fairly close, within a few hundred hertz of the correct frequency. And you also need to do pre-processing to get rid of some of the interference. I asked ChatGPT how to fix the issue of the amateur radio call signs, and it came up with a number of ideas. One of the ideas was just simply to pre-process the text coming out, and when it sees something like G4GUO as 3 different words, sticking them together as a call sign. And I also asked it, is Whisper a large language model? And it said no, it's not. It then went on to describe in very great detail how it works. Basically, it takes a load of spectrograms of what it's doing, and then using the trained data, it tries to match them, and that's how it does its decoding. So I also then asked it whether you could fine tune Whisper for this type of thing, and it said no, but it also did tell me that there's some unofficial forks which can be partially fine tuned. Right, the next project I tried, and I demonstrated this a while ago on the QO100 net, was to actually add subtitles to the TV picture. I must admit, it's just a gimmick more than anything else. I'm not really quite sure why anybody would want to actually add subtitles, uh, other than, well, I find subtitles annoying on YouTube, so sticking them on my own transmissions is probably not that great an idea. The way I did it is you can put a text box using OBS that reads from a file and then just keep overwriting that file from the Whisper program. And this was an example of the output. This is me a few years ago. And in the same room as I am at the moment, but with a load of boxes, camera boxes actually, that's on the back. But Reeve was trained on American spelling, so as you can see, it can't spell color and things like that. But that's neither here nor there. Other ideas I had about this, well, you can clone your own voice, you can clone someone else's voice for that matter. So you can maybe have a chatbot on 2 meters, and so people think you're talking to you when you're not. And another idea I had, which I think is cheating, would be if you're DXing, you could take your voice, turn it into text, and then turn the text into someone else's voice that's more appealing for pilot operation. I'll leave that to the imagination. Right now, the latest topic, of course, everybody's talking about since the advent of chat GPTs is large language models. So what can we do with those? I have had a few ideas and tried a few things. Now, the first project I tried was to use it to write Verilog code. I thought, well, it's probably been trained on Python and C and Rust and all those other strange languages. Let's try something it's not that likely to actually seen that much. So I got it to generate an I2C controller in Verilog. In fact, this is the actual board. It's a FPGA, some outputs, and a GPS receiver and a serial port, which is I'm doing that for a project which if I don't have time for, I'll discuss later. Now, what happened? The code didn't work. So I tried asking it 4 or 5 times with exactly the same prompt to generate the Verilog code. Each time it generated a different version of the program. Eventually, I found a version of the program that I could understand and correct. So I sort of got it to do Verilog. If you ask it to do something simple like a down counter or something like that, easy peasy. It has no problems with that. But anything more sophisticated, and it struggles. The next thing I tried doing was, all right, I wonder if it knows anything about GNU Radio Companion. So I gave it a large text description, a sort of formal description, telling it exactly what I wanted it to do and how I wanted it done and what techniques to use and things like that. And I fed that into it, and it produced a GNU Radio Companion graph. I'm not quite sure. Yeah, here we go. This is what it produced. I asked it to do a multi-mode receiver for GNU Radio, and it does in fact work, except the AM part works, the wideband FM part works, the narrowband FM part works, but the 3 at the bottom, which were upper sideband, lower sideband, and CW, didn't work. So we had another go, and I thought, well, let's try building a GNU Radio out of tree module. So it went ahead and did that. Didn't work. I mean, it compiled and everything, but it didn't work because every time they update GNU Radio, they seem to change everything. And so I went back to my text prompt and I told it exactly what version of GNU Radio I wanted it to create for, and tried again. It worked a bit better this time, but it still wasn't really up to the job. So and it was a bit of a disappointment, but to be expected. So that's just with using, I used ChatGPT originally, but then I went on to use Claude 4.5, which is supposed to be a lot better at coding. And in fact, it is, in that the code is easier to read, it documents it better, and it generates test scripts and what have you, so that you can test the code. So I thought, right, okay, let's try something else. So the next thing I thought, well, I've got one of these Kenwood expensive radios that's got a general HF receiver in it, as well as being a handheld. And I thought, it's always difficult to program these things because they're so complicated. I thought, all right, let's try that. So I told it, tell me how to configure my handheld radio to receive. And so on I've got a local version of well, it's GPT OSS, which is the open source version, and on that I fed it a copy of the Kenwood manual and the question that I wanted, and it did come up with a set of a script to tell me how to do it and how to go through the menus and what have you. But it left out one important piece of information. So I tried again on ChatGPT itself, you know, the one that you can use on the internet. And this one, that version, which is a much, much larger model, got it right. The important piece of information being that the general coverage receiver can only operate on VFOB. It won't work on VFOA. My local AI didn't know that, and it was telling me to use VFOA, so that was a fail. The next thing I tried was to configure my pfSense router, which is what I pass my internet through when it comes from the modem, and I wanted to add a VPN to it, and that it was successful in telling me how to do it. Then I had a discussion with it on HF channel equalization, which is something I've been trying to sort out for many, many years. Those of you that know my history know that I did a program for decoding aircraft transmission on HF, and that required an HF channel equalizer in it. It's not the most brilliant, but I've been told of all the ones out there at the moment, it's the most successful. The most useful use for I found for AI is as a coding assistant. So you can't tell it to do, you can't do what they call vibe coding. Say, write me a website that does such and such type thing. It's not up to that when you're trying to do something more sophisticated, but it can be useful to help you, especially me and Python, in that I'm not a Python expert. I've never had to write Python in my life professionally, and now I'm retired. Obviously, I'm trying to learn it. And another thing it's useful for is summarizing documents. It might be useful for summarizing, say, Chinese data sheets for components and things like that, because a lot of the models now can actually do, they can look at images and tell you what's in images. So that's one use that might be quite good. We'll get back to the screen. Well, as I said, I haven't found it much good at vibe coding, which is the buzzword at the moment. Um, and I use it as an assistant. This is just basically what I was saying before. It's the thing to do is to generate a sort of pseudocode of what you want done, and then tell it to do to write the code for you. One example is I was trying to do a sliding window for a text window, and I thought, oh, this is going to take me lines and lines and lines of code in Python. So I told the AI to do it for me, and it did it in 5 lines of code. Now, there's no way I could have done it in 5 lines of code. But they're definitely improving. I mean, a year ago when I was trying to do this, it was the Python code it generated. It used out-of-date libraries, and it was just a mess. But these days, it's getting a lot better than that. And the ability to just highlight some code that doesn't work and say, what's wrong with this code? Or to take someone else's code and highlight it and say, can you tell me how this code works? It's definitely makes life a lot easier. Now, there are ways of improving how an AI works. I'm going to speed up, I think, because I'm coming to the end of my my allotted period. You can do prompt engineering. That's where you tell it in the prompt exactly what you give it information. Like, for example, an AI normally doesn't know what the day and date is. So in the code, the AI code I've used, in the system prompt, I actually tell it what the day, the date is, etc., who the user is, and then it knows, and it can do clever things like you can say, without giving it that information, you ask it, how many days until Saturday, and it says, I don't know. But once it knows the date it's been given that, you can say, how many days till Saturday? And it says, oh, today's Saturday or something like that. So that's useful. And recently, Anthropic have introduced a thing called the Model Context Protocol. This allows you to actually make calls, function calls from the LLM. You give it a load of tools, and you tell it, or the protocol tells it, this tool is for searching the internet. This tool is for retrieving data. This tool is for looking at an image or something like that. And then it will actually call these tools one by one, and which makes it a lot more powerful. I use it so I can interrogate my solar power system, and also I can ask it what the temperature is and various other things. And I've used it to control GNU radio, to send commands to GNU radio to change frequency and stuff like that. So right, next we got the RAG, which is retrieval augmented generation. This is where it makes database calls, normally via an MCP call, and it can pull information that's specific to the application that you're interested in. So you could feed it, for example, it could have a database of the radios you're using and stuff like that, or frequency charts, or it just adds knowledge to a general purpose AI. And you can also fine tune the model. I've done some fine tuning. I trained a model on back copies of CQTV a few years ago, and it suddenly started to know about the BATC. But quite often you asked it who's the current chairman of the BATC, and it'll tell you who the chairman was in 1948 or something. So it's not exactly what was planned. And then finally, the latest buzzword in AI is agents, where you have these little models working in unison with one another, and models supervising other models and doing things like that. But you can generate, specialist agents using the techniques above to do particular things, and then the supervising agent says, oh, I want you to do this, I want you to do that. But at the moment, that's where all the money is as far as the industry is concerned. But I'm not convinced it's much use at the moment. Okay, you've seen that diagram. This is the outer tree module it produced. It it generated the Python bit all right, and the C code it didn't quite get right, and it stuck it in the wrong place. Then I thought, well, this is about artificial intelligence. I'll ask ChatGPT what it thinks AI could be used for an amateur radio. And this is just I've just processed the information because it produced about 5 pages of what you could do. Obviously, exam and generation from tutoring people, interference analysis, pattern recognition. I actually saw that someone on Grok was receiving interference, and they cut and pasted onto Grok, which is the AI for X, or Twitter as formerly known as. They cut and pasted a spectrogram of that and asked it what it was. And Grok came back, said, this looks like an over-the-horizon radar system, probably made by such and such, and then listed where it knew where these things were installed. So, it has been trained on that information. And I've certainly used it with Smith charts. I've shown it Smith chart and said, what's this? And it said, oh, that's a Smith chart. And I said, what's the load? And it said, oh, it looks as if it's connected to a short circuit, because I only had a short circuit, an open circuit, and a match load as examples. I haven't tried it with anything more complicated than that. The other thing it could be used for is looking for people intruding on the amateur bands, propagation prediction using information like you can get free supply sources of weather information, things like that for Tropo. Antenna design. I mean, you can use software that analyzes antennas, and you call that via MCP calls, and use real physics to check the results are okay. MCOM message handling, sorting out priority messages, is really good at analyzing and messages. Hands-free operation. There's a micro version of Whisper which will run the Raspberry Pi, which would allow you to control your radio, say if you're mobile. Smart radio data networks that knows where everybody is and works out optimum paths, etc. And how do you get started? Well, you can use the free tools, ChatGPT and Claude 4.5. The free versions of those are limited, but you can get through about one design with ChatGPT before it says you need to pay. Claude 4.5, similar thing, and you can share the work with other people. It generates a web link that you can share your work with. You can run local models on your graphics card. You really need about 16 gig of memory or more than that. Or you can run it on your CPU. And if you've got an Apple Mac, they've got a special set of instructions, MLX instructions, I think, for artificial intelligence. And quite a few of the architectures, like Olama, can cope with that. And but I mainly use GitHub Copilot and VS Code, mainly because I'm paying $100 a year to use it, so might as well. And it's an integrated environment, a bit like an editor, but you can ask the AI by doing Control I, and it'll come up and gives you a little box, and you can either ask it a question or you can tell it to write code. And then about the most useful thing is Hugging Face, which is a website that has a load of open weight models from everything you can think of, from speech recognition, speech detection, chat bots, and all sorts of stuff, and vector algorithms for generating embeddings for searching databases and what have you. And that's it. I'm ready for any questions if there are any now.
Okay, Charles. Yeah. Well, we have a good 10 minutes left before the
Yeah,
next
well,
presentation.
that was the plan.
Absolutely, yeah, absolutely. So if you haven't already asked a question, I've seen one, or at least a comment there, which I'll read you in a moment. But then please do put them onto BATC or YouTube chat, and I'll relay them to Charles as well. Thank you very much for that overview, Charles. The thing that occurred to me most actually is at the beginning of your talk, you showed us a certificate from your NVIDIA course, which was 2019. And I mean, I think to most of us, AI, at least spoken about regularly, feels like a couple of years old. But then I and lots of others, I'm sure, watching this who sort of have an engineering mind will realise, I think, that AI is something that's actually been developed for years and years and years, really. It's just that it's now getting to a practical speed.
Fuzzy logic and things like that.
Yeah, exactly. And it's sort of just something that's got faster so that it becomes almost immediate now and becoming a mainstream for everybody to use. Do you agree with that?
Yeah, certainly. I mean, the conversation I had with that PhD students, I was sort of thinking, oh God, they've been at this for donkey's years and it doesn't really work that well and what have you. And but she put me straight on that.
Yeah, absolutely. Yeah, I'm a bit worried for my doing something like this actually, because I can quite see that within a year or two, and I've got some friends who still work in radio, and they're quite concerned, because at the moment, you've got newsrooms who create journalists sit down and create news stories, and then they type them up, put them on a screen, and then hand them to somebody to read. Well,
mind you, have you looked at YouTube Shorts recently? Because it's full of AI slop, and within seconds you can tell that it's computer generated and it's not a real human that's behind it. And there's just something wrong. It feels wrong.
Well, thanks, Charles. That gives me hope and confidence. But it's both clever and a bit concerning, I think, in both ways. So anyway, at home, you've got a few minutes now. If you do want to ask Charles any questions about the work that he's done, the experiments he's done, this is the time to put them onto BATC or YouTube chat, and I'll read as many as I can to him. So first up, from Michael, EA7KIR, he's got a comment for you, really. He says that I find GPTs to be helpful with Golang, I guess that is, but when I'm very, very persistent. However, its training data is out of date. That's what Michael thinks.
Yeah, that's why organizations are using things like RAG, the retrieval augmented generation, where you keep a local database of up-to-date information, and things like what I've created my own chatbot, which is based on GPT OSS 120B, but I've given it tools to search the internet. So, for example, without those tools, if you say who's the president of the United States, it says Joe Biden, because it doesn't know any better. But when it can actually search the internet, it says, oh, it's you know who, because it can actually go out and find that up-to-date information. Another thing I found is that ChatGPT won't look at BBC website because they've got robots.txt in there to stop it sucking information out of from the BBC. But my local chatbot doesn't have any restrictions like that, and it can suck up information from virtually anywhere, even if there's a robots.chat or robots.txt file on the web page. Which is just interesting. Also, mine, I've disabled it, but apparently the search library I'm using can actually search the dark web as well.
Oh, goodness me. I don't know anything about that. I don't think I want to, but I didn't know about this robots.txt either. That's fascinating. So, but, who knows? It's, as I said, both fascinating, intriguing, but slightly worrying, I think, at the same time. Got one little question for you from Mike, G0LJF, who says, with people, has the Turing test been passed by AI?
Oh, that's very debatable. They now think that the Turing test is too simple.
Oh, really?
Yeah.
Oh,
they're looking at more. I mean, they're getting it to do math Olympiads and things like that now.
Well, it's fascinating. That's all the questions I've got there. But of course, just a reminder to everybody at home, there will be an open session for around about 30 minutes or so at lunchtime, which we're calling our ATV packed lunch. and you'll be able to get onto a Zoom call and then ask there. Oh, actually, I have got one other question. I'm not sure if this was meant for you because someone else answered it, but it might be meant for you. I'll quickly ask this. Can we get AI to correct lip sync, which are those of us, of course, who do a lot of this streaming and stuff and over QO100 and things, trying to align our lip sync means it's the lining up the lips moving with the sound. So do you think that's something that AI could do quite well? It feels like it should.
It could do it, but it's interesting because I was watching a YouTube channel that specializes in artificial intelligence, and they were talking about lip sync in there, and they do it manually.
Yeah, well, I must admit that's how we do it here. We've got, nowadays with digital television, we can delay or advance things to make it work. But you never know. You never know.
But I mean, one thing that they have been experimenting with is just transmitting the they digitize the face at either end, and then they transmit information that tells the thing at the other end to move the mouth and things like that. And I think they can do full video, headshot type video in kilobits, sort of 2.4 kilobits or so, just by saying, the mouth is moving and things like that, and the computer at either end then moves the mouth to follow what's being said.
I've no doubt is to come. Charles, thank you so much for this insight into AI, what you found useful, a little glimpse maybe of what it's going to do in the future. Thank you very much for the talk this morning.